Hello, this is Team JAC, also known as Jack. My name is Jaqueline Covarrubias.
My name is Caraza.
My name is Conor King.
And today we're going to show you our arbitrary function generator. We're going to start by giving you a simple glimpse of what the app does, and then we're going to dive deeper into explaining the more complex details about it.
How it works.
Exactly.
Okay. This is the main function. We have some extraneous material over here, but the main stuff is here. So we can change the shape of the graph. Its default is sine wave, but we can also set it to rectangular, triangular, sawtooth, FW rectified, and pulse. Okay. When we have a sawtooth, we can change how nice it looks by adding more sine waves. That's the summation depth here. If we take it up to 1,000, it becomes a much smoother graph. If we change this to pulse, this button pops up and we can change the ratio of highs to lows, like that, for a different kind of wave. We can change the frequency. Let's make it even 10 times as big. Or we can make it much smaller. Yeah. Let's take it back to sine. Make it real big. We can make it real small. All kinds of stuff. Amplitude just increases the size of the wave. You can see it's now to 6 and 6. And the DC offset just changes where the zero axis is for this graph, where the baseline AC is, DC. Alrighty.
And the default?
And default brings everything back to its original settings. Sine, 440 Hertz, which is A, positive polarity, 100 depth, 0 offset, 1 amplitude.
Alright.
Okay, so we also have in our app, we have two different tabs. We have function 1 and we have function 2. And what's pretty cool about that is that you could either have the option of turning one off and then keeping the other one on, or vice versa. You could turn this one on and then turn this one off. Okay, the point of two graphs is so that we could see what they both look like together. So as you can see, there's a sine graph on function 1, and then there's a rectangular wave on the second one, and then that's what they would look like together on the main axis.
Alright, now we're going to get into the property of sound. Any wave that you choose in any of the two functions, you have the option of playing the sound. It's going to play the sound for 2 seconds. We also have the option to change the frequencies, and we added a little fun aspect to the project in which we can see pictures of living creatures that can hear the sounds being played. So for example, if I go to a very low frequency that humans can't hear, then we can see like which animals can actually hear that sound. If we go to very high frequencies, there we go, 26,000 frequency, and we have whale and a bat. So lastly, we have the main axis, and it has the option to play the sound of both waves combined. So if we go to function 1 and we play the sound, and function 2, play sound, and now the main axis can play both.
Let's take a look at the code that makes the app work. We're going to start at the very top and work our way down. Here we have properties of the app. This is where data is stored. Here we have the X and Y data that makes up the main graph and the axis limits of that graph. And we have the same thing for the first graph and the second graph. This is where the pictures are stored. And these are some extraneous ones that make some fiddly things in the app run better.
Alright, next we have the function that Serge gave us. This is the function that sets a max buffer size. The only aspect about this that we have to explain is that whenever we go to very high frequencies, we're going to notice how the graph normally looks kind of not what you expect. Now, that's the only downside to it, but at the same time it helps us run the app more smoothly. It lets it continue without crashing.
These two functions are designed to read in data from each tab of the app, from function 1 and function 2 respectively, and they're called in this function, which is what actually creates the X and Y data. It reads in the correct data from where it's called, then it uses the function that Antonio was talking about to find the correct number of points to plot, and basically just runs a math program. It adds a bunch of sine waves together that are specified in Fourier transforms to get the appropriate y values, and then it stores them in the property that we mentioned here.
So next we have the creation of combining the waves together. So basically it was the same as what Connor had talked about before. The only difference is we would have to rename them as axis limits 1 and axis limits 2, and we basically did that for the rest of the functions in here. And then if you go down, we have 2 if statements. One is for the function 1, and then if you keep going, this is for the function 2. So basically, like I said, the only difference is the renaming of them, and it ends around here. And this is the waveforms. The x values stay the same, and then you have to add the y values together.
Next we'll show you the functions that produce the actual graphs. They're rather simple. They set the axis of the graphs to be correct from the data that we've stored up above, and then they plot the x and y values from the data that we've shown up above. Same for graph waveform 2, and same for the main one.
Alright, so now we are going to show you how we load the images. So here we have the IMRED for every one of the pictures, and then we have a block of code. This part, pretty much what it does, it goes back to Matlab. The important part is to have all the pictures stored in the same folder, just like that. That's all the pictures right there. This will take those pictures, like select those pictures from the folder, and then read them, and then we go up to the function, the actual function that shows the animals. There it is. For example, the pigeon. If the frequency selected is in between 1 and 2000, then it's going to show the picture of the pigeon. And that's with every picture. And then we added an extra line of code that if there's an odd number of pictures being shown, for example 3 or 0, then we add a picture blank instead of just having a black square on the screen. So I'm going to show it to you. If we have, for example, three pictures shown, then we have a blank for the 4th square. Then we have the functions for the sound. This is specifically for the play buttons. So this is the play button for the first graph. And so it's really simple. We have the y values taken from the app.waveform. Those are the properties from the first function. And then we select the sample frequency. That one is set to the buffer given by Surge. And that produces the sound for the first function. It's the same thing for the second function. And then down here we have the play button for the master graph, which just plays the first and the second function at the same time.
And finally, we have all the functions that are the options, functions, and buttons that basically if you change it on the graph, this will reflect it on the graph. So that's all the rest.
So one last thing, let's check if the frequencies played are the right ones. We have a spectrometer, 440 frequency. 440 goes up for rectangular. It says 1324, but remember that's an overtone. Let's go to 440. About there. 440 goes up. Triangular. 440. Sawtooth. Works. FW. Good. Pulse. Good. And if we bring up the frequency, 1440, and that was a 1441. So it works. Thank you for watching our arbitrary function generator.
And also, don't forget to hit the frequency up to 200,000 to 300,000.
Thanks for watching and have a great day.